Hello, you are welcome to Maths Clinic Multimedia Series. And in this video, we are continuing a series of probability. In our last lesson on probability, we talked about the definition of probability, some basic terms that we use in probability, and we also studied the reason why, or we saw the reason why we have to study probability in school. Today, we want to continue the series of probability. And this time around, this is our objective. What we want to achieve by the end of this section, we'll be able to determine the sample space of simple experiment, determine the sample space of compound experiment, and then calculate the probability of an event. These are the objectives for this very lesson. So let's start with sample space. Last meeting, we saw the definition of sample space, and I told you that we're going to look at it in a broader perspective. To talk of sample space, we said in our last lesson that is a set of all possible outcomes of an experiment. If you perform any experiment that you're not sure of the outcome, or the possible outcome that can possibly come out, put it that way, is sample space. For example, if I say a match between two teams, or a football match between two teams, what are the possible sample space that should come out? If we have a football match right now, the possible sample space we know can be either win, loss, or draw, unless the match is a final match where we always want the winner or maybe the loser. I mean, one just would want to get a winner. But if it's a normal one, we have three possible outcomes. And these possible outcomes makes up what we call the sample space, the set of sample space. All right. Then another example is tossing a coin once. If you toss a coin once, what are the possible outcomes? A coin can appear either head or tail. Remember, a coin is 50-50 chance of happening. That is if the coin is not biased. And so the sample space is head and tail. You can be writing all these facts down because you need to use them as form of revision. Then tossing a coin twice or tossing two coins once. Now they are the same. If I say tossing a coin once or tossing two coins, tossing a coin once or tossing two coins, tossing a coin twice rather, or tossing two coins once, the possible outcomes will be either I toss and get each of them appearing head-head, or head-tail, or tail-head, or tail-tail. These are the possible outcomes if I do the tossing of coins once. Right. So that is that. All right. Another example can also be tossing a coin thrice, or tossing three coins once. So if you toss three coins once, or you toss one coin three different times, they all come out with the same possible outcomes. And so the possible outcomes you are going to have is, if you can pause the video and try generating all of them and see that whether you're going to get the same answer as what I have here. And so we have head, head, head. That is a possible outcome when the three of them will appear all heads, or the first two will appear head, and then the last will be tail. Or we can have head, tail, head. We can have head, tail, tail. We can have tail, tail, tail. We can have tail, tail, head, and head, tail, head, tail. And finally, we can also have tail, head, head. You can say these are 8 different outcomes, which will be the sample space. And the number of sample space here is equals to 8. The number of sample space is equals to 8. And so in the general term, we can say that tossing a coin or coins, the sample space is given as 2 to the power n. Very important to take note of this. You can note it in your note, 2 to the power n. What it means is that your n is the number of coins or the number of times a coin is tossed. So that if you toss maybe a coin 4 times, if you do 4 times, then you are going to have 2 to the power 4. and 2 to the power 4 will give you 16. That means the sample space will come out as 16 different possible ways of appearing. So we can have sample space to be maybe head, 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 4. Then it keeps on going that way until you get all the 16 possible outcomes. So tossing a coin 4 times, like we said, will give us 16 times. If it is 6 consecutive times that are going to toss this particular coin, then you should expect something like 2 to the power 6, and that should give you 64 possible outcomes. So here we will say the number of sample space is equals to 64. That's what it means. Now let's look at this in terms of die. Throwing a die once. What is a possible outcome? If you know you have your normal die, when you throw it once, what normally happens will be either 1, 2, 3, 4, 5, 6. These are the possible outcomes when you throw the die once, right? That's the possible outcomes, right? So we see the number of sample space is 6. Then what if you have 2 dice and you are throwing them once, or you have 1 die and you throw it first and you throw the second? Any of them, once it involves 2, either 2 times or 2 dice throwing once, the possible outcomes will be like this. So we can put this in a table form as this. So here we have die 1 and die 2. And so die 1, the possible outcome is 1, 2, 3, 4, 5, 6. And then die 2, the possible outcomes goes that way, or other way around. I mean, whichever way you go, it's the same. And so the possible outcome is going to be either we throw the die and the die 1 comes as 1, whilst die 2 also comes as 1. That is a possible way. Or die 1 will come as 1 and 2 will come as 2. 1, 3, 1, 4 in that order. It can also be that die 1 will appear as 2, whilst die 2 appear as 1. And that can also move on 2, 2, and then we get it all. Or we can have die 3 appearing 1, 3, die 1 appearing 3, and then die 2 appearing 1. And that will also go through that. And the total number of sample space we can get for this is going to be that is n of x will be equal to 36, right? So that's the total number of sample space. Now, in general term, when we have a die, the number of sample space that can be generated out of throwing a die depends on the number of times. And so that becomes n, 6 to the power n. Very important formula to keep as well. So here we say where n is the number of times a die is thrown. So what it means is that if you are throwing 2 dice once or tossing 1 die twice, you are going to get 2 to the power 6 to the power 2, which will give you 36. And if you do this for 3, 4, 5 times, then you can imagine the number of times you are going to throw, the number of sample space you are going to get. Right. Now, interesting fact about math. I like bringing some of this part across my slides. Have you ever noticed that the opposite side of a die always add up to 7? Go and pick a die. Observe this. You see here being 5. Opposite side of it, the under rate should be 2. So they add up to give you 7. Here being 4, the other side should be 3. They will add up to give you 7. Here is 6. The opposite side here becomes 1. It must add up to 7. And so amazing. Or it works throughout. It works throughout. Right. Now, let's take another experiment and see how we can generate a sample space. This time around, we say this is 6-sided die, and then number of marbles here. There are 1, 2, 3, 4, 5 marbles. And the question says that, or maybe the information here says that, as shown in the figure, a marble is drawn from a sack and a regular die is rolled. And so I roll a die, then I pick a marble from the sack. How many outcomes are possible in doing this? You throw a die, you pick a marble. You throw a die, you pick a marble. And so let's assume that I do the first one. And the first one, I pick this one and I throw 6, or I had 6 as the outcome. Or possibly I can also have dream and still have 4 as outcome. I can have two outcome and pick red. I mean, so how many ways can we get this sample space? And so when you put this in a table form, like we did earlier on for the two dies, this is our marble, this is our die. Die goes 1 to 6, and the marble also we have 5 of them with 5 different colors. So it's possible I can roll a die and get 1 and pick red, or I can roll a die and get 2 and pick red in that order, or I can pick the violet and then throw 1. I mean, so we can get our sample space like that. And again, if you count the number of possible outcomes, we have 30 of them in all. So that means the total number of sample space is 30. Right. Now let's look at classical definition of probability, which is going to lead us in solving questions involving probability. Classical definition. Now we are going to now define the probability in the more mathematical way. If a sample space is made up of S equally outcomes, for example, we have a sample space of, let's say, throwing a die once. These are the possible sample space that we have, right? And we are saying that if a sample space is made up of S equally outcome, that means any of these can equally come out. And if exactly A of this outcome correspond to the event, then we can say that probability of the event is equal to the number of sample space over the number of, so the number of events over the number of sample space. Now what it means is that if my event in throwing this particular die, maybe my target is to get even number. In that case, the even numbers become my event. That is what I'm targeting of achieving. And so the even number will be 2, 4, and 6, right? So what we are saying is that for me to know the probability of this event, what is the chance of me throwing a die and get 2, 4, or 6? What is the chance? What is the possible outcome or the chance? My chance of getting 2, 4 is going to be the number of the event, which is 1, 2, 3 of them, over the number of the sample space, which is 1, 2, 3, 4, 5, 6. When I divide this over that, I get a probability of me obtaining that. So if assuming that I'm having, let's say I'm having a game of throwing a die, and I tell you that come and throw a die. If you get even number, I will give you 50 Ghana cedis. If you get odd number, you give me 50 Ghana cedis. I'm sure you might want to try your luck because the chance of you winning is 50-50. But if I say throw a 6 and you get 50 Ghana, if you throw anything apart from 6, you rather pay me 50 Ghana. I'm sure you'll be very careful in doing this or playing this game, because your chance of winning is going to be 1 out of 6, but here your chance of winning will be 3 out of 6. And so that is what probability is all about. Let's look at some few basic properties of probability, then we take questions and solve. Probability values from 0 to 1. I think we've said that earlier on our first video. If you've not done that, if not watch it, go back and watch that lesson and then you will understand this concept very well. For that matter, mathematically, we can say probability of events lies between 0 and 1. And because I've explained it already, I wouldn't waste time on that. The probability that sample space will occur, if I have a sample space of 1, 2, 3, 4, 5, 6, these are the possible outcomes of throwing a die once. And I tell you that, oh, throw a die once, you get 1, 2, 3, 4, 5, 6. Any of this number will appear. Then the probability is certain. I mean, because there's no way you can get any number outside 1, 2, 3, 4, 5, 6. So we can say the probability of sample space occurring is 1. That means that's a certainty. Then probability of an event can never occur also is 0. Like I would say, out of the sample space of throwing a die once, like we did, okay, what is the probability that when you throw a die, you're going to get 8? That's not possible. And so that probability, so the probability of event of throwing 8 is going to be the number of the event doesn't exist, so to be 0, divided by the sample space, which is 6. And 0 divided by 6 is the same as 0. So we are saying that the probability of empty set, which is no element in the event, will give us 0. Then finally, one of the most important property we have to take note of in probability, which of course is more or less like a law, is this particular property here. It will help you in solving so many questions in probability. If P of A is the probability of an event A, that the event A will occur. Let's say it can be even number will occur or odd number will occur. Then the probability that event A will not occur is called the complement of event A, which is denoted by this. Now, let me explain further to this because it's very, very important. Let's assume that I throw a die once and we know this is a sample space. Then I said my event is going to be probability of finding an event which is a number greater than 4. A number greater than 4. So E is a number greater than 4. So what are the possible values of E in the set here? A number greater than 4 will be 5 and 6, right? So what is the probability of this event E? Is going to give me the number of the event, which is 2, over the sample space, which is 6. And so the answer becomes 1 over 3, right? Then if this event does not occur, if I don't get 6 and I don't get 5, what are the other possible ways I will get? I will get an event which we call complement. I mean, those that will not occur will be 1, 2, 3, and 4. Then to find the probability of this event does not occur will be 4, because there are 4 items here, divided by the sample space, which is 6. And of course, this can be reduced to the lowest form as 2 on 3. Now, what we are going to understand is that the probability of the event occurring, which gave us 1 over 3, plus the probability of the event not occurring, which is giving us 2 over 3, together must add up to give us 1. Very important. So the probability of event occurring and it not occurring must always add up to give you 1. So in conclusion, with all this information here, what we are saying is that if A denotes probability of the event occurring and A prime, or sometimes you put bar on top of the prime, I mean the A, some people also make it A prime like this, showing that it will not occur. If you sum them up, you always get 1, as we've already explained. Or if you try to make this one the subject, it will be 1 minus 8 occurring. Other way around, if I make this one to the subject, it will be equal to 1 minus this one as well. So it works in both sides. Let's take some few examples to end this video, to end this lesson. Example number 1. A bag contains 8 yellow, 4 red, and 6 blue balls, all of the same material. That means they have the same material, the same size. Okay, the same material and size. That means if you put your hand in it randomly, you can pick any one without being biased. If some are bigger than the other, then you can be sure of you picking a bigger color or a smaller color. But since of the same size and the same material, that means it's not biased if you have to drop your hand and pick any randomly. Now, if a ball is picked at random, a ball 1 is picked at random, what is the probability of getting a red ball? And what's the probability of getting a blue ball? And what is the probability that a ball which is not blue? So how do we handle this question? Now let's look at the solution here. These are the solutions, but let's look at how we get the answer. So first of all, we want to know how many balls are in the box or are in the sack. There are 18 of them in all, right? Because if you add 8 plus 4 plus 6, you get 18 balls. So that is the number of sample space up. That's So let me write, number of sample space is equals to 18. That is letting S represent number of sample space. We can also let Y represent number of yellow balls, which are 18, or we can also let red represent number of red balls, which are 4. And then finally, we can let B represent number of blue balls, which are 6 in all. Now, our first question is here, we should find the probability that if you pick only one ball, that ball should be red ball. So probability of red ball. So it means for us to know the probability of you picking a red ball, you must know the number of red balls, then you divide it by the number of sample space. That is the classical definition that we saw. The number of red over the number of sample space. The number of red ball, we know we have 4 here. Sample space gave us 18. So when you divide this by that, you have 2 out of 9. Then that's first question number 1. Question number 2. Question number 2, we want to find the probability that if you pick the ball, you're going to get a blue ball. And that also is going to be the number of blue balls in the box over the number of sample space. The number of blue balls, we saw that to be 6. Sample space is 18. And this, again, we divide. So 6 divides itself 1 and divides here as 3. And so if you look at the answers that we saw here, the first one is 2 on 9, and the second one is 1 on 3. What about the third one? The third one, right, we are going to say probability of a ball which is not blue. So if it is not blue, then it should be either yellow or red. Or we can also say if it is not blue, then it will be non-blue. So probability of we getting non-blue is equal to probability of 1 minus blue, using the fourth property. Let's do these 2 solutions. I will say that, okay, if I say probability of non-blue, if I subtract the total number of blue from the sample space, I have non-blue to be 12. So number of sample space, number of events, which is not blue, is 12 divided by 18. And when you simplify this, 3 divides here as 4 and 3 divides here as 6. Or I can even do something better of. I can pick 6 to divide the 12 as 2, and the 6 will divide 18 as 3. And so the answer is 2 over 3, right? That's what we saw here. Very good. 2 over 3. Now, if I choose not to use this approach, I can use the fourth property, which says that probability of the event, and this event, let me call this whole event as event A. So probability of event A, okay, or let me make it, let me use rather A prime for it to show that it's not blue. So if it is not blue, or better still, I can still use a symbol that came for blue, which is B. So let me use B here. Okay, so probability of not blue is going to be 1 minus probability of blue. This is what we brought up in the property, right? Probability of not blue is equals to 1 minus probability of blue. So this is going to be 1 minus, and probability of blue gave us what? 1 over 3. So 1 over 3. That's what we calculated earlier. Probability of event blue is this one. So if we do 1 minus 3, of course, the LCM is 3 here. 1 divides 3 as 3 times this will give us 3 minus 3 divides 3 as 1. And we multiply by 1, we get 1. And so when you subtract, you get 2 over 3. So we get the same answer as we have. And so the idea of we using the property works. All right. So that is question number 1. Now let's try question number 2. Let's try question number 2. You can pause the video and try your hand on it. So you keep trying and see if you can get the same answer. I'm sure your answer came as 3/8 or 3/8 for exactly 2 heads. 1/8 for no head, and then half for at least 2 heads. Now let's go through the solution together and see. 3 coins are tossed once. There are 3 of them tossed once. So you can see the 3 coins here tossed once. Now the possible outcomes is the sample space, of course, is going to be either we get all heads or head, tail, like we did earlier on. So these are the possible outcomes for all. And so here we can say that our number of sample space becomes 8. Good. Now, the question says we should find exactly 2 heads. We want to find the probability of 2 heads. So we can generate the event. We can maybe let A be the event of exactly 2 heads. So we figure out all the 2 heads in the question. So let me clean this part first. Then we generate that one and see. So event A, let it be the exactly 2 heads. So we can see let A represent exactly 2 heads. Now let's figure out from here. Exactly 2 heads. Exactly 2 heads. Here we have 3, so this is out. Here we have 2 heads, so we can have head, tail. That is 1. Exactly 2 heads. Here too we have head, T, head. That means exactly 2 heads. We have 2 heads in it. Then comma. Here we don't have, so this is out. This one too is out. Here we have only 1 head. Here 1 head. Here we have 2 heads. So again we have T, head. So these are the possible outcomes of the event. And so we can see this implies that the number of event A is equals to 3. Now I want to find the probability of getting the event A, which is called exactly 2 heads. Because I've already defined let A be equal to exactly 2 heads. If I bring A, anybody who is marking will understand. So the probability of me getting A is going to be the number of A, which of course we know that, and the number of sample space. So number of A is 3, sample space is 8. And so the answer becomes 3/8. Then I can also use another letter to define no head. So again, if I do that, I can say let maybe B be equal to no head. No head simply means, that is the question number 2. No head means I don't have a head at all. And here we have head, here we have head, here we have head. No head is here. So this is what we need. Here we have it, here we have it, here we have it. So no head appear as tail. That's where we have only, I mean no head. And the number of sample space is 1. And so the probability of getting B will be equal to 1/8. And that is why the answer gave us that. And the last question, let's use C to represent event of at least 2 heads. Now here we have to be very careful. At least 2 heads means that in each case there must be a head in it. In each case there must be a head in it, either a head or more. We say at least means 1 or more. At least 2 heads means at least 2 heads means 2 or more. That means no matter what, there must be 2 heads or 3 apples. Good. So let's search for all heads that are either 2 or more. Either 2 or more, that means this one is parts. So let me clean this one, and then we see, let's clean whatever we have here, right? So that we can tick and circle those ones that are possible to this question. So at least 2 heads means this will qualify because it has 2 or more. This will qualify. This will be, this is not because this one is 1. Here, no, because we don't have it at all. Here is out, here is out, and here is in. So what do we have? We have head, comma, head, tail, comma, head, tail, head, comma, and then tail, head. So these are the possible, and they are 1, 2, 3, 4. And so we can see the probability of getting that C would be 4 over the total sample space of 8, and the answer will give us half. And so the answer for that question is half. So you can see from our previous slide that the possible answer that came out was this, that, and that is true for that. Good. And so that is the answer to that. We can solve this particular C also by using the fourth property, that is probability of an event occurring and it not occurring is equals to 1. And so we can say the probability of C is the same as 1 minus probability of C not occurring at all. And C not occurring at all, we can also see that C not occurring at all is going to be all those that we cancel, like this one, 1, 2, 3, 4. And that is going to be 1 minus 4. And 1 minus 4 over 2. And note that 4 over 2. So here we can say 1 minus 4 over 8. Sorry, 4 over 8 is the same as half. And 1 minus half is the same as the half that we see here. So the answer will still come as such. Right. So we will end this lesson here. But then I want to give you, okay, let's take one more example. There you go. This one a bit different from the ones that we've solved. So let's try question number 3 so that we can end the video, and I'll give you questions to solve on your own. Now, a box contains 20 balls. So like this one, we see this box here contains 20 of them, S of which are green. So we have green balls. That means there are possibility of underweight some colors which are not green. If the probability of selecting a non-green is 3 on 5, find the value of X. 20 balls are in all, some of which are green, the rest are not green. We don't know the number that is green. Okay. Now, I want you to pause this video, try solving this question on your own, and let's see whether you get your answer. So some few minutes, you can pause the video and do that. I'm sure your answer came as S being equal to 8. If that is your answer, you give yourself a thumb up, you've done well. If not, then let's see how we can solve this question. And so bear in mind that we are still having 20 balls. So we can say the number of sample space is equals to 20, but you can solve this question in so many ways, so many ways. S of which are green. So the number of green balls is equals to X. So if the whole box contains 20 balls and S are green, then the number of the non-green, okay, that's non-green, will be 20 minus X. Agreed. Because 20 balls are in the box and S of which are green. Then those that are not green, if I subtract S that are green from the total number, I'll get those that are not green. And so that will give us that. Then the question gave us the probability of selecting non-green is equals to 3 on 5. Selecting non-green is equal to 3 on 5. Now, if you want to define probability of an event, let's say the event of not green, it should be equal to number of the non-green over number of sample space. This is what we've defined all this while. So the probability of non-green has been given as 3 on 5 rather. And the probability of, so that is that. So the number of non-green, we said that is 20 minus X over sample space, which is 20. If I do simple cross multiplication, then I can have 5 into bracket 20 minus X is equals to 3 times 20, which is 60. If I expand this, I have 100 minus 5X is equals to 60. I simplify this, I can write it as 5X, if I group like terms, is equals to 100 minus 60. And of course, 5X will give us 40. and we divide both sides by x, then, sorry, by 5, then we have x to be equal to 8. You can solve the question this way. You can use different methods to solve this. Anytime I give this question in class, I get different feedbacks. I mean, different methods used to solve the same question. So you can try your hands on more other questions that are ahead of you. So try your hand on this. Example 4, you pause the video, you solve it and see whether you get these 3 answers. Then example 5, that one too, you pause the video, try your hand on it, and this will be your answer. Sorry, let me go back again. This will be your answer. So you pause the video, you try, you solve it, and you let me know your solution. You can send your solution to me. You have my number, so you can send it to me on WhatsApp. Or you can put it on the platform, of course, the platform that we are on now. So the next question is question number 6. A game is played in which a coin is tossed and a die is thrown. So you construct a table for it and you solve, and the answer will give you 1/4 or 1/4 as your possible answer. Then question number 7. 2 dice are thrown once. What is the probability of obtaining a total score of this? At least 9, exactly 10, and so on and so forth. And all these are the possible answers you will get. I think finally, this question, you have to take your time and go through it. And when you do it, you get these 2 possible answers. With this, we come to the end of today's lesson. It's quite lengthy, but I'm sure you've learned a lot. You can go back over and over to watch the video so you can get the best out of it. Our next meeting, oh, okay, there was a third question to this, which is 7/8, right? Our next meeting, we are going to look at compound events and then look at other independent events, mutually exclusive, and then we'll solve questions on that as well. So thank you so much for watching. Stay blessed.